Hey, we're looking at section 8.3, solving right triangles. So in the previous section, you could do sine, cosine, or tangent to find side lengths. Now to find angle measures, we can use inverse sine, inverse cosine, inverse tangent. So let's kind of go back to section 8.2, what we looked at first. So we had sine, cosine, and tangent. So let's just use sine, okay? So sine of an angle that equals a fraction. So for sine, opposite over hypotenuse. For cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So now let's remember what we did in algebra. You worked with inverse functions. So the x and y, input output, they switch with each other. So now let's look at that. So inverse sine, sine to the negative 1. So to create that inverse, you're going to swap the input to the output, angle and fraction. So now inverse sine of your fraction, opposite over hypotenuse, will give you the angle that you want, okay? So let's kind of look at this in practice. We have, let's fill this up first. So sine of angle A is x, then inverse sine of x. It's really sloppy writing. Let me zoom in a little, make it better for myself. So swapping inputs and outputs. So inverse sine of x would give you the measure of angle A. Cosine of A equals x. Then inverse cosine of x adjacent over hypotenuse would give you measure of angle A. Tangent of A equals x. X tangent opposite over adjacent. So now inverse tangent of your opposite over your adjacent. It's going to equal the measure of angle A. So looking at this triangle over here, triangle ABC of 7, 12, you want to find angle A. So write an inverse cosine equation. So cosine, remember, is adjacent over hypotenuse. So here's angle A. Here's our adjacent, 7. And our hypotenuse, 12. So inverse cosine of 7 over 12, that amount, will be the measure of angle A. So go ahead, oops, I didn't even do that. Go ahead and get a calculator to do that. And to do inverses, you want to press second cosine. So let's see if we see that. You get the cosine of that backwards, made that backwards. So you get the idea. Inverse cosine of 7 over 12. Make sure in degree mode 54.315 degrees. Alright, so still using the same ratios, but finding the angle measures using inverse sine, cosine, or tangent. So what this can allow us to do is to find all measures of a triangle if we're only given some of them. So triangle SRT. We have two sides, 5 and 5.7. We have the rectangle S. So we need to find angle T, the measure angle R, the length of SD. So let's find the measure of angle R first. Now in relation to R, you have the 5, which is adjacent, the 5.7, which is hypotenuse. So adjacent and hypotenuse, this is going to be inverse cosine of 5 over 5.7. So calculator inverse cosine of 5 over 5.7. And you get 28.694 degrees. Now, nice thing, you remember the triangle sum theorem, right? All the angles in the triangle have to add up to 180. So the measure angle T is 180 minus the 90 minus the measure angle R, 28.694. So quick, plug that all in. I don't feel like doing them in the math. And you get for the measure angle T 61.306 degrees. And because you have two sides, you could use reverse Pythagorean theorem. So ST is equal to the square root of the hypotenuse squared minus the other side squared. So square root 5.7 squared minus 5 squared, 2.737. Now for the other triangle, example 1, you only have one side, so you'll need to use a trig function after you use an inverse trig function to find the measure of side EF or FD. So take a look at that, then check your answers with my complete notes online.